Get into it. Section 4.7, we are going to use isosceles and equilateral triangles. Some of these properties we've already talked about a little bit. But as a refresher, let's classify these by their sides. Number one of each side is 2 centimeters.
That's an equilateral.
It is equilateral. Yes, I would expect you to spell it out if this were a question on a quiz or a test. What about number 2? Isosceles. Okay, we've got 2 sides that are the same. Then it's isosceles. What about number 3? Scalene. None of the sides are congruent. Questions about these? All right, number 4. In triangle ABC, if the measure of angle A is 70 degrees, measure of angle B is 50 degrees, what's the measure of angle C? 60 degrees. How did we come up with that? Good. All 3 angles should add up to 180 inside of a triangle. So if you add up the 2 that you already know and subtract that from 180, that gives you what the last one should be. In triangle DEF, the measure of angle D is equal to the measure of angle E. The measure of angle F is 26 degrees. What are the measures of angles D and E? 77. How do we come up with that?
Don't you, add the 26? Wait, no, never mind.
Detriana.
I subtract the 26 from 180 and divide by 2.
Perfect. 180 minus the 26 gives me what's left over. 154. And then we take that, divide it between the 2 angles that we have left. We get the 77 degrees for both of those. Questions about our warm-ups?
No.
Ready to get into our notes?
Never.
Well, ready or not, here they come. All right, first up we have the base angles theorem. If 2 sides of a triangle are congruent, then the angles opposite them are congruent. So the short version uses this diagram. So if, let's pick 2 sides to be congruent. Okay, so I heard AC and AB first. It doesn't really matter if you know 2 sides are congruent. So AC is congruent to AB. Then the angles opposite those sides would have to be congruent. So what angle is opposite side AC? What angle is opposite side AC? Angle B would be congruent to the angle that is opposite side AB. That would be angle C. So if we know those 2 sides are congruent, then we know the angles opposite them are congruent. Questions about the base angles theorem? Need more time on this slide. Okay. The converse of the base angles theorem, of course we should know what a converse is. If 2 angles of a triangle are congruent, then the sides opposite them are congruent. So this time we're starting off with a pair of angles. What angles do you want to use? Okay, we could use C and B again. Now we start with congruent angles, then we can conclude that we have congruent sides. So what side is opposite angle C? Side AB is congruent to which side? AC. The ones across from or opposite them. So we conclude that those sides are congruent. Are we all okay with the idea of opposite? Angles and sides that are opposite of each other. Yes, no, maybe so? Kind of, sort of? Maybe not? Okay, we'll see how it goes. Name two congruent angles given that FH is congruent to GH in triangle FGH. It might help to draw a triangle FGH. It's not entirely necessary, but it might help us to. So FGH, they said sides FH and GH are congruent. So I'll mark those. FH and GH. So it's asking which two angles have to be congruent.
Angle F is congruent to angle G.
Angles G and F would be congruent. Those ones are opposite those sides that are congruent. Questions about example 1? Okay, we'll move on. Find the measure of angle X and angle Z. What do we know about the measures of angle X and Z just based on the diagram? They're congruent because the sides opposite them are congruent. We know that those two angles have to be congruent to each other, so how are we going to figure this out? Subtract what from 180? Okay, subtract the one angle that you know from 180. What does that give me? And then what do I do with that? Divide it by 2 because we're splitting it between those two angles. And what do we get? 65. So the measure of angle X, which is equal to the measure of angle Z, is 65 degrees. Questions about example 2? Okay. Next up would be a couple corollaries that we have to the base angles theorem. Remember, a corollary is something that can be proven or shown easily given that theorem. So, given the base angles theorem, it would be easy for us to show that if a triangle is equilateral, then it is equiangular. Again, we might have already talked about that a little bit. If all the sides are congruent, then all of the angles are congruent. The corollary to the converse of the base angles theorem, if the triangle is equiangular, then it is equilateral. It works both ways. If all the angles are the same, then we can conclude all the sides would be the same. Now, this does not mean that sides are going to have a measure of 60 degrees. The sides and the angles are not the same as each other. It just means the sides together would all be the same. Separate from that, the angles together would all be the same. Okay, it still happens every now and then that I ask you for a side length and somebody gives me an angle degree measure. We can't mix those up. Questions, concerns, need more time? Okay. Find the measure of angle R, angle S, and angle T. Well, just based on the diagram, what kind of triangle do we have? Equilateral, which means it is equiangular. So all these angles have to be the same or congruent. Anybody figure out what they are? 60. If you're ever unsure, you could label them each with an X. And you could say, well, I know if I add all of them up, it should equal 180 degrees. And then you have yourself a pretty easy equation to solve. I am not expecting that you would show that work every time or really any time. If a triangle is equilateral, equiangular, then the angles will always be 60 degrees. So all three of them 60 degrees. Anytime it's equilateral, equiangular, it will work out this way. Questions, concerns? Okay, this is only for equilateral, equiangular. So this is not something that you can apply to other triangles. Just because an angle isn't listed does not mean that you can say it must be 60 degrees. So don't do that. It's very specific to these triangles. All right, we are asked to find the values of x and y in these diagrams. This large triangle, there is technically a black arc in the very bottom of it, which means the larger triangle, KLJ, is what type of triangle? Equiangular, which means it's also equilateral. Are we all okay with that? Can we see that black arc down there? It's a little easier to see with the different colors, in my opinion. If this triangle is equilateral, because it's equiangular, what does x equal? 8. So in this case, x equals 8. So now, essentially, we can ignore the bigger triangle. So I'm just going to take most of that away. We don't even need this segment in here anymore. I'll take most of that away. Now, looking at this triangle that we have left, what type of triangle is it? Isosceles, because we've got these two base angles marked congruent to each other. So what could we set 2y equal to? 8. Or x, yes, because that's the side across from it. So remember, in isosceles triangles, the sides opposite those angles have to be congruent. So 2y has to equal 8, which means y would equal 4. So x equals 8, y equals 4. Questions about how we reasoned our way through letter A? Okay. On letter B, again, x is going to be the easier one to identify, in my opinion. Anybody identify it? 7. Okay, so we've got this equilateral, equiangular triangle on the left side, which makes x equal to 7. Okay. That would also make this side equal to 7. Now, what's not great about this diagram is that things are not drawn very proportionally. But we're all okay with all three of these sides being 7, right? Okay. So I'm going to, again, kind of take away most of this triangle that we don't really need anymore. Or a little too much of it. So this side that we have left that they shared, that was also labeled 7. Again, this triangle's not drawn to scale. But what type of triangle do we have if we know we have two base angles congruent? It's an isosceles triangle, which means that the sides opposite them, regardless of what they look like, are congruent to each other. So what equation can we set up? Y plus 4 equals 7, which means y equals 3. Okay, so sometimes you have to go just based on how a diagram is labeled, not what it looks like, because those sides don't look like they should be the same. But based on the information they labeled, they are. Questions, concerns?
No.
Okay, so in my opinion, this was a pretty easy lesson to end on. Your homework should be on your homework sheet. This is our book work. However, we are going to have another assignment that I want before class is up. So I would write this down, but I'm about to give you a worksheet that I want you to focus on first.